Okay, Panthers, you've had a chance now to put the heading on your new ISN page. It's page 106. You knew, I'm sure, to see that on the whiteboard or the blackboard as you came in. We're going to graph some tougher systems today. The bottom line is that not every linear equation is written in slope-intercept form. There are two ISN pages, if you were with us last semester, that I find helpful today. And I'll briefly remind you of how that works. I'm going to take this off the page for a moment, and I'm going to turn back to page 77. Panthers, the reason that we keep these notes in the ISN is so that we can look back at what we've worked on previously when it's needed. You have a page 77 in your ISN where we practice the skill of looking at a way to find the graph of a linear equation if I did not know what the equation looked like in slope-intercept form. Or in other words, if the equation was not solved for y. Here's a great example to look back at. If you want to look back along in your notebook, you can. If you'd rather watch it here, that's fine too. We give you an equation, this is probably back in November sometime, where the equation was not solved for y. And I think we tried to sell you on the idea that the easiest way to graph that line would be to find the x and the y intercepts. So in this equation, negative 3x minus 5y equals 15, we kind of did what we called the cross-out method. To find the x-intercept, we said let's cross out the y term and just write the equation what it would look like without the y term. Negative 3x equals 15. If negative 3x equals 15, you can divide both sides by negative 3 to show that x equals negative 5. Okay? I actually think the graph we made here is incorrect. It's funny that we're looking at it that way. I think it should actually be right here. So you can ignore that graph that's there. Let's look at let's make a new one. I'm going to pretend I did that on purpose, okay? The y-intercept, Panthers, is the method is going to be to cross out or cover up the x term. Pretend the x term is not there and write the equation the way it appears. Negative 5y equals 15 means y is negative 3. The mistake I made back in November was I plotted the intercepts on the wrong axes. When y is negative 3, x is 0. So these 2 points are points on your line. And as soon as you have 2 points on your line, you can use that pattern. In this case, it's down 3 over 5 to make more points. Down 3 over 5 more. So the graph I made in my notebook is not the one you need. You need to make this. Well, that was a lousy graph. But you get the idea, I hope. That's the principle I want you to apply today when we're practicing graphing these tougher systems. Now I'm going to take the book away and just focus on the pink half-page handout. Okay? So, Panthers, this item A is a system we want you to solve by graphing. The system is y equals negative x plus 2 and 4x plus y equals negative 4. Now, this first equation is in slope-intercept form. The way we practiced graphing yesterday will work for this. You can only graph this way if y is already solved for. Since y is solved for here, you can graph it by finding 2 on the y-axis. And then, just as we practiced yesterday, figure out a fraction that means the same thing as this slope. In this case, it's negative 1. And a fraction that means the same thing as negative 1 might be negative 1 over positive 1. Yesterday, a lot of you found it helpful to remember to always put, if the slope is negative, to put the negative sign in the numerator. So this slope is rise over run. And what this means is from this point, I should go down 1 and right 1 to find new points. So from the point I had, y equals 2, I'll go down 1, right 1. There's a point. And I'll go down 1, right 1 again. And so forth. In fact, I'm going to do this. I'm going to try and fill the graph as much as I can. Just because I never know exactly where the solution point might happen. Here's my first line. Now my second line is not already solved for y. So you've got a couple of options. You can either solve that equation for y, which you could probably do, or what you might try is the cover-up method, or try to find the x and y intercepts. So for this second equation, to find the x-intercept, I'm going to cross off the y term, or forget about the y term. And I'm just going to write what I've got left. 4x equals negative 4. And you can solve that equation for x. You know the x-intercept of line 2. If I divide both sides by 4, I get x equals negative 1. So let's go ahead and plot the x-intercept. The x-intercept is where the line crosses the x-axis. To find the y-intercept, I need to cross off or cover up the x term. So get rid of the x term, and if you did that, all you would have is y equals negative 4. There's nothing to solve there in covering up the x term. You already solved it for y. So let's graph the y-intercept as well. And what you can do now is you can graph other points that fit the pattern of from point to point, down 4, right 1. If I go down 4, right 1, again, I'm off the graph, but I could go left 1 and up 4. There's my solution right there. And left 1 and up, well, that last point's off the graph too. So my second line looks like this, and there's my solution. So just like we practiced yesterday and discussed in the opener this morning, from the origin I need to count to this point. I need to go left, right first. So back to negative 2, and then up to 4. The solution is negative 2, 4. One down, 2 to go. Let's take a look at B. In B, neither one of these is solved for y. So what I might want to do is I might want to work each one separately. I might want to start with 2x plus y equals 4. Negative 4, rather. And I'll find the x-intercept. I'll cover up or cross out the y term. If I cover up the y term, the equation reads 2x equals negative 4. And if I solve that equation for x, I'll divide both sides by 2. That means that x is negative 2. So I can plot that x-intercept. The x-intercept is negative 2. To do the y-intercept, of the first line, I need to cover up the x term. And that just tells me what the intercept is. So I can write down the y-intercept. It's just y equals negative 4. And I can plot the y-intercept. And now I've got a pattern of down 4 and right 2 that will let me plot other points on the line. There's one line down, 1 to go. So now let's do the second line. X plus 2y equals 4. To do the x-intercept, I need to cover up the y term. And if I cover up the y term, it just says x equals 4. That's kind of nice. So I'll go ahead and plot that on the x-axis. There it is. And to do the y-intercept, I'll cover up the x term. Now the equation says 2y equals 4. And if 2y equals 4, and I divide both sides by 2, then y is 2. So I can plot that point as well. And it looks like my pattern to graph this line is down 2, right 4. Or left 4 and up 2. There's another point on my line. That's also going to be the solution, isn't it? Good. So what's my ordered pair answer? Start at the origin. Looks like I need to go left 4 and up 4. So how about negative 4, positive 4 as a solution? Okay. We've got one more. Let's look at C. Oh my goodness, look at that first line equation. X equals 2. Let me take you back to that page 85 in the ISN very quickly. So what we told you on page 85 of the ISN is that if you have a line equation of the form y equals some number, that's a horizontal line that goes through that number. This line is y equals 4, where every y coordinate is 4. If you just have an x in your equation, then that number that x equals tells you every x value in the equation. In fact, there's the line we're supposed to graph right there. X equals 2. I'm glad we had the notebook to look back. So that first line is very simple to graph. To graph x equals 2, I just need to find where x equals 2 on the horizontal axis, on the x-axis, and plot a straight up and down line, like so. Now this second equation is not solved for y, so let's find the intercepts. The x-intercept, I'll cover up the y term, and it simply says 3x equals negative 6, so that's what I'll solve. If 3x is negative 6, then x is negative 2. Right there. To find the y-intercept, I need to cover up the x term. Now be careful here, don't lose that negative sign. That negative sign goes with the thing after it. So if you cover up the x term, you've still got negative 2y equals negative 6. And if negative 2y is negative 6 and you divide both sides by negative 2, you're going to get y to be positive 3. And it looks like my pattern for graphing is up 3, right 2. So I'll do more, up 3 and right 2. Or I can go left 2 and down 3. But I already know where these are going to cross. My solution is this point right here. It's 2, 6. Okay. And we've got it. Okay, Panthers, what's left for you to do today is this. You need to glue that 106, that half pink sheet into page 106. You then need to refer to it while you're working in class today on today's classwork right here. 116. It's LT 19 day 2. It's another handout. This is another one of the homework things, or classwork things rather, that's going to be collected from you on Friday. I want to remind you that tomorrow you're going to have your mastery assessment over the objectives 17, 18, and 19. So use this time wisely, Panthers. Make this a productive rest of your day. And I look forward to seeing you tomorrow.